Welcome to this technical deep dive on identity and access protocols. We will cover SAML, OAuth 2.0, OpenID Connect, and WS Federation, providing a comprehensive guide to their flows, architecture, and troubleshooting. Our agenda covers core concepts like authentication versus authorization, followed by deep dives into the protocols. We will then look at live examples and finish with essential troubleshooting techniques and tools. Let's start with the foundations. Authentication, or AuthN, verifies who you are. Protocols like SAML and OpenID Connect handle this, resulting in an ID token. Authorization, or AuthZ, determines what you can do, and OAuth 2.0 is the main protocol for this, resulting in an access token. We begin our protocol deep dives with SAML 2.0, which stands for Security Assertion Markup Language. SAML is an XML-based open standard for exchanging authentication and authorization data between an identity provider, or IDP, and a service provider, or SP. It is dominant in enterprise environments and relies on pre-exchange certificates for trust. This diagram illustrates the service provider-initiated single sign-on flow. The browser acts as the transport mechanism. The user visits an app. The app generates a SAML request. The browser redirects to the IDP, and after authentication, the IDP sends the SAML assertion back. The SAML request from the SP to the IDP is an XML AuthN request, often base64, encoded and sent via an HTTP redirect. The response from the IDP contains the digitally signed assertion and is sent via HTTP post binding because the XML is typically too large for a URL parameter. A real-world example is Salesforce single sign-on. Instead of seeing a password box, the user is seamlessly redirected to their company's login page, such as Microsoft, demonstrating the SAML request in action. Common SAML troubleshooting issues include clock skew, where server time differences invalidate the assertion. Certificate mismatch is another frequent problem, as the SP needs the correct IDP public certificate to verify the signature. Simple PowerShell web requests can help test endpoint reachability. Next, we explore WS Federation, which stands for Web Services Federation. WS Federation is an identity protocol that transfers identity information using SOAP messages and XML. It is functionally similar to SAML, but primarily used in older SharePoint and AD FS environments. While it often uses SAML tokens, it differs in the URL parameter used, utilizing WSign-in 1.0 instead of SAML request. The WS Fed passive profile is designed for browser-based access. The user accesses the resource, is redirected to the Security Token Service, or STS, authenticates, and the STS posts the token back to the resource. A classic real-world example is a SharePoint login backed by AD FS. When selecting Sign In with Organizational Account, the URL query string shows, quote, equals WSign-in 1.0, identifying the application to AD fluorine monosulfide. Troubleshooting WS Fed often involves checking for realm or audience URI mismatches. The WT realm parameter must exactly match the relying party identifier in ADFS. Claims rules must also align, and misconfiguration can lead to infinite redirect loops if the application rejects the token and sends the user back to the STS. Our next protocol is OAuth 2.0, the Open Authorization Framework. OAuth 2.0 is the industry standard for authorization. It functions like a valet key, granting an application limited access to a protected resource without sharing the user's password. This enhances security by using a token instead of credentials. OAuth defines 4 key roles. The resource owner is the user granting access. The client is the application requesting access. The authorization server issues the tokens. The resource server hosts the protected resources. 2 primary grant types are the Authorization Code flow, which is the most secure method for server-side web apps, exchanging a temporary code for a token. Client credentials are used for machine-to-machine communication, where a backend service authenticates with its own credentials. In the Authorization Code flow, the user authorizes the app. The server returns a short-lived code. The client secretly exchanges this code for an access token. Finally, the client uses the token for API calls. The defining moment of OAuth is the consent screen, such as the one used by Spotify. An application requests permission to access certain resources, but never sees the user's password, only receiving a token with restricted scope. OAuth troubleshooting frequently involves a redirect URI mismatch, a critical security feature where the URI must match the registered one exactly. Expired tokens require the application to use a refresh token to obtain a new access token. PowerShell can be used to manually test if a token works against an API. The final protocol we will discuss is OpenID Connect, or OIDC, which is an identity layer built on top of OAuth 2.0. OIDC standardizes how identity data like name and email is shared, bridging the gap that OAuth left for authentication. It introduces the ID token, a structured JSON Web Token, or JWT, that the client reads to verify the user's identity. A JSON Web Token has three parts: the header, which specifies the algorithm, the payload, which contains the claims or data, like the user ID and issuer, and the signature, which validates the integrity of the token. The OIDC authentication flow is very similar to OAuth, but requires the, quote, OpenID scope. The server returns both an ID token and an access token. The client validates the ID token signature and then uses the user information to personalize the experience. Social login, such as sign in with Google, is the most common OIDC example. The site redirects to Google for authentication and receives an ID token on return, allowing the site to create an instant user profile. To troubleshoot OIDC, you can use a JWT inspector to verify the ID token's claims, like the issuer and expiration. Nonce validation is crucial to prevent replay attacks. Also, check the discovery endpoint to ensure the application can locate the necessary keys and endpoints. To summarize, the identity protocols we have covered each serve a specific purpose, ranging from authentication to authorization. This matrix provides a quick reference comparing the primary purpose, token format, typical use case, and main actors for SAML, WS Federation, OAuth 2.0, and OpenID Connect. Thank you for watching this video. We hope this deep dive into identity and access protocols has been helpful.